Hello and welcome. I'm going to be tackling another model-off problem this evening. This is a question from round 5 of 2021 called What's My Net Worth? So we've got an individual who owns a business. We've got the EBITDA for the past year. The model is as of the end of 2019 and forecast for the coming year. And a valuation multiple, so we can value his business. He owns various real estate, his own house, a summer house, and an apartment. And we have details of mortgages on each of those, and also details of the market rent and capitalization rates, so we can get to a valuation. We have details of Mr. Smith's and Mrs. Smith's cars when they were bought. They each lose 20% of value in the first year, and then another 12.5% per year thereafter. He's got a small stock portfolio, Microsoft, Tesla, and General Motors, and he owns different numbers of those each month throughout the year. And then he's got a small cash balance on hand as well. And so the challenge is basically to build a monthly model starting 31st of December 2019, running to the end of December 2020 to work out the family's net worth at each stage through the period. I actually recorded a version of this video earlier, and then I realized I just kind of waffled on too long. So I'm going to try and keep this one considerably tighter and just kind of focus on some of the more interesting aspects of it. So a couple of quick setup things. First thing, I'm going to take this block of real estate assumptions and I'll just switch over to my version 2 of the assumptions tab here. I'm going to pivot it so that rather than having columns for each property and rows for each line item, I'm going to have the line items across and the properties down the side. That's because the way I'm going to lay it out in the model is with a row for each of these three. So if I have it set up with all the information across one row, then I can set my references here, locking in the columns, and then copy it down, and it'll do the same thing for the next two apartments automatically. Cars are already set up that way, the stocks are already set up that way, everything else is good to go. And then the second thing is I'm going to take these stocks and go data types, and convert them into stocks, and it'll spin for a second, and then you'll see that MSFT ticker has turned into this little stock symbol and Microsoft Corporation, okay, so having done that, here's the sort of shell of the model that I'm going to build. So we're going to do business equity, real estate split by the three properties, stocks split by the three cars, his and hers, cash, total assets, and then we're going to do liabilities. Whoops, I've still left in version of that from before, get rid of that, and then get to net worth. Again, I've done all the kind of setup here already from my earlier one because I don't want to make you watch me do that again. Okay, so I'm actually going to start with the last piece in sequential order here because I think that's actually the most interesting one, with a lot of different ways to do it. So one of the things that I wanted to sort of highlight in today's video was thinking about some of the trade-offs. I've talked about this a little bit before, of like, when do you want to have supporting schedules? So a mortgage like this is a pretty obvious example. You've got a mortgage that was taken out, let's say 6 years ago when you start the model at the start of 2019, and has been kind of working its way through. So you would probably immediately think, oh, well, obviously I'm going to need to model that whole mortgage. And so again, I'm just going to do, here's one I've made earlier for that. This is a kind of typical monthly mortgage model. If you're not familiar with how to build those, I have other videos covering that. Specifically, I think I have one called Debt 101. I'll put a link if I remember, but just search Debt 101. I'm sure you'll find it. So you got your opening, your interest, your payment, principal plus interest, and your closing. And obviously the whole nature of a mortgage is that principal plus interest amount stays constant throughout. It lasts 25 years, so 30 months, and it gets to 0 at the end. So that is all kind of behaving as you would want. And so then basically your option one is to just build that whole supporting schedule, and then XLOOKUP this here, returning from here. And I should lock those so I can copy across. And I guess I'll put a negative sign on it because I want this to be a liability. Or actually, no, sorry. I set this up so I'm subtracting my liabilities. So positive sign is good. So obviously the advantage of this is you've got all the supporting details here if you need it. The disadvantage of this, not a major one, but somewhat of a disadvantage, is if everything in here is linking off to supporting schedules, then you can see, okay, this is where the information is coming from, but you can't kind of analyze the logic that's going into it in this place. So the alternative, and this is kind of probably as extreme a case as I would look at it for. Most of the other all the asset items are just a little bit more straightforward, but that's why I'm starting with this one, because it's more interesting. The alternative is basically to try to kind of model this, all in a cell. Now, in the old days, basically if you made a large and terrifying and enormous formula in one cell, that was kind of almost by definition bad and unauditable and problematic. The thing that has changed in recent times is the availability of the let function. And let, if you haven't used it, it's a relatively new function, basically lets you define a name 1, and then give it a value, and then you can basically define as many pairs as you want, like this name gets this value, this name gets this value, this name gets this value. And in all your subsequent calculations, like in figuring out the value of later names, you can use your existing names. Let's say that rather than figuring out the balance, we want to figure out the mortgage payment. Then here's what I mean by how you can document your formula. So if I said let annual rate be this, and let purchase price be this, and let down payment be this, and then so let's say I want to work out what's the loan amount, and I'm going to say that is purchase price times 1 minus down payment. And then what else do I need to work out? Term, let's say I do term years is this, then I can say term months is term years times 12. What else? Let me just expand this out so we can see all of it. I want my monthly rate. That's annual rate over 12. Then I think I've got all the different pieces I need. So then my monthly payment can then be PMT monthly rate, comma, term in months, comma, PV is the loan amount, and that's it. Sorry, and then I need to enter an output. So the output I want to give is my monthly payment. So that's one example, and you can see 2911 should match up with that 2911. We give it 2 more decimal places, we get to 57 cents. So that's good. So this one's a little hard to read because there's not much space, but if you space these out, I'm not going to do line breaks for all of these just because I've put in so many small definitions here that this one would get enormous if I did put in line breaks for all of them. But you can see, and again, you don't need to be quite as verbose as this. Like you can go straight to, you can go straight to a monthly rate and straight to a term in months without having these separate definitions. But the point is that when you lay it out in this way, it's very easy to see, even though there's a lot going on here, it's very easy to see the logic. Okay, so I get the annual rate from some assumption cell, I get the purchase price from some assumption cell, down payment from some assumption cell, the loan amount is the purchase price times 1 minus the down payment, that makes sense. I get the term in years from some cell, term in months is that times 12, makes sense. Monthly rate is the annual rate divided by 12, makes sense. Probably would be more sensible to put that one next to this one, make it a little easier to read, but you get the idea. And then the monthly payment is just the PMT function of the monthly rate, the term in months, and the loan amount. So what you've got is effectively kind of documentation of your logic by having all these names throughout here. And then, none of those names exist. Like if I say and rate over here, it doesn't exist. It only exists within the kind of, opening and closing parentheses of the let function. So that's what I mean by saying you can get some sort of documentation of a formula. So how would we arrive at this value without a supporting schedule, but with a documented formula? Let's work through it. So first thing is we want the loan amount, because I'm going to use that in a couple of places, and that's going to be purchase price. And for this, I'm going to lock in, so F4 3 times to lock in the column, but not the row, because I want it to copy down and refer to this one in the next row and this one in the next row. That times, oops, sorry. So when you hold down Shift and press space, you get this slightly annoying behavior that you're maybe not expecting. I'm just trying to put spaces in my formula to make it a little easier to read. So 1 minus the down payment. That's the loan amount. And then the second thing I need to figure out is how many periods have passed. So I'll just skip along a little. I'll say, call it months in. And that's going to be, I want a year frac to tell me how many years I'm in of this starting date to the ending date, which is today's date, so $4. And then I'm going to multiply that by 12, and just to be extra safe, I'm going to round that to a whole number. So that's how many months into the mortgage I am. So then my next thing I'm going to say is payments so far. And here I'm going to, let me just put if you ever need to kind of stop partway through editing a formula, if you just put an apostrophe before the equal sign, it'll convert it into text. Okay, don't want it wrapped. And then you can move away and then come back and complete it, rather than, if I just delete that and hit enter here, it'll say error, you can't basically stop editing a formula until it's complete. So I'm going to do that and come over here. Just mentioned, so I showed you the PMT function here, and I've again talked about it in other videos, but you can also break this into the interest payment and the principal payment with IPMT and PPMT, and it basically takes the same arguments, except you also have to specify the period number, because the total principal plus interest stays the same in every period, so that's why you don't have to specify it for that one, but the interest changes every time and the principal changes every time to balance the two of them out. So my payments so far are going to be PPMT, and I'm going to take the rate, and that's an annual rate, so divided by 12 to get a monthly rate. The period number, I'm going to take a sequence, so I want all the period numbers. I want how many months in I am. So in other words, here I'm going to take, I want to find out the principal payment in period 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to whatever number of months in I am, which, like in this case, we're 6 years in, so it'll be 72 payments. Then the number of periods is going to be the loan term in years times 12, because again, our periods are months, and the present value is going to be that loan amount. So that's my list of payments so far. And then let's just make that the output for a second. And obviously I get spill errors here because I've got other things here, but now you can see. So it gives me a list of, count them, 72 principal payments. And that's all the principal payments corresponding to, so this is principal plus interest, but if I net them off, you can see I get 170,119. Copy on down for a while. And if I bring these numbers in, whoops, you'll see, if I match the format, it'll be more obvious. You'll see that these are all matching off as we go along. So that's my list of payments so far. So then my closing balance is going to be my loan amount, the original amount I borrowed, and note that these all have a negative sign, so I'm going to say plus this, oops, got that row reference there again, plus the sum of my payments so far. And then what I want to return is closing balance. And if you have a good memory, you'll remember that that is the exact number we had in there before, but if you don't have a good memory, let me just cut that formula, put it down here, and then I'll copy and paste that XLOOKUP back over there. And now hopefully we'll see that it matches the whole way along, and we do. So happy days. So that's working. Now I just need to refill these formulas here that I deleted to make room for the spill. But actually, sorry, before I do that, let me show you this. So if you know a thing or two about let, you will know you don't need to do this. Like a name doesn't need to be your last thing. This calculation can be your last thing. The reason that I'm sort of defining a name for my output and then outputting that name is because that actually makes it a little bit more audit friendly. So here I have the balance after 72 months. But let's say I want to check, hang on, is it calculating the number of months that we are into it right? Then I just replace that name in the output field with months in, and it tells me I'm 72 months in. Okay, but is it calculating the loan amount right? Let's check that. 675,000. Okay, that looks good. Is it doing, let's check the full list of payments so far. Give me the whole list and I can check that. And then basically once I've done all my auditing, which can spill out to kind of as much space as I want, a bit like this guy over here, once I'm finished with that, I can then say, okay, that all works. Let's go back to outputting closing balance. And that way I don't have to, I only have to change a name here and I'm outputting different pieces from along the way. So that is a neat way to do it with let. This is still, a list of payments based on the sequence function is slightly advanced stuff. You need to consider A, what you're comfortable with, and B, what your client or end user or whoever is comfortable with. But if you're a reasonably advanced Excel user, or if they are, or whatever, then this level of documentation may be plenty without needing to have a separate tab for every different bit of it. So anyway, let's copy across, copy down. That gives me all my different mortgages, and then the assets side of things is somewhat more straightforward. So let's start with the business equity. So we're interested in a multiple, 8.5x multiple of trailing 12 months EBITDA. So as of the end of December, my trailing 12 months is just going to be those. So I'm going to say sum, and you can see I've already made this red because I know that my first one here is going to be a different formula. I'm going to multiply that by the valuation up here. So that's the value of the business at the start, and then I'm going to say this. So basically the idea is, starting from this 12, I need to subtract off January of 2019 and add in January of 2020 to get the 12 months for the next month. And then the next month I'm going to want to subtract off February of 19 and add in February of 20. So I'm just going to say equals this plus my 8.5 valuation multiple times the EBITDA I'm adding minus the EBITDA I'm subtracting. Close that, carry it across. So now we've got business valuation all the way through. Told you that part was more straightforward. Real estate, we're valuing on cap rates and market rents. So we've got market rent for each one of them, monthly rent for 2019 and a cap rate, and monthly rent for 2020 and a cap rate. So here we're just going to say the monthly rent for 2019 times 12 gives the annual rate divided by the cap rate, gives you the valuation at the end of 2019. And we do the same thing for 2020, the monthly rent times 12 divided by the cap rate gives you the valuation at the end of 2020. Did I get that right? Yes. And so if I flip between these, I should just see M changing to N and O changing to P, which I do. Good. And then in between, it changes as a kind of continuous exponential. So in other words, it's going to be the first one times so the overall change over the year is the ending value over the starting value. And I want to do a month of that at a time. So I'm going to take that to the power of my month counter up at the top, divided by 12. And copy down, copy across, copy down. And then my sense check here is, does that change by the same rate every month? And the answer is it goes up by 0.88% every month. So that is behaving as we want it to. So we move on. Stocks. We've already got our tickers here. So I'm going to take the number of stocks we have times the value, and we're going to get that using the stock history function. That's why I converted these into stock data types. So I'm going to lock in the column. Start date, I'm going to, I guess I'll come back over here, be a little more proper, $4. And now there's a lot of different settings you can make in here. Because I'm interested in monthly close, I'm going to set my interval to monthly, no header, so I just want the data, and the only data point I want is the closing value. And I've already got the number of stocks held to multiply by that. So I just hit close, it's busy for a second, and then it's done. So then again, I copy that down, copy it across, busy, 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 done, done, done. All happy. All right, cars, Mr. Smith's car, Mrs. Smith's car. So again, here, I'm going to use the let function rather than kind of having a supporting schedule. I'm just going to use the let function. Why are these still saying busy? Oh, hang on, just move off and back again. Okay, there we go. So I'm going to say let, so I'm going to say let purchase price be this. I'm going to lock that in. I'm going to let the years old be, again, I'll use year frac to figure out the difference. So this was bought, again, we're looking at Mr. Smith's car, first row, so that was bought then. And $4 was my row with the dates. This time I'm not going to multiply by 12 because I'm looking for years. And then the next thing I want is my year one depreciation. So it loses 20% of its value in the first year. And again, the kind of more detailed notes here say where you've got partial years, you basically, so in other words, over the first year it goes from, X to 80% of X. So if you have a partial year, like say a half year, then you would take the square root of 80%, or in other words, 80% to the power of how much of a year you have. So in this case, year one depreciation is going to be 1 minus 20%, so that's how much goes down in total over the first year, to the power of min of 1 and years old. So in other words, if you're more than 1 year old, you get the smaller of these two is 1. If you're less than 1 year old, then you get a partial year of depreciation. Then I want post year 1 depreciation, and that's going to be 1 minus, 1 minus this guy, 12.5%, to the power of, again, the number of years after the first year. So simplistically, that would be years old minus 1, but then, and in this case, that would actually work because these are both at least a year old, but you want to allow for the possibility that one of them will be less than a year old, so that these assumptions can be varied later. So we're just going to say the max of that and 0. So that's my depreciation, and then my current value, curval, is going to be purchase price, I can spell, times year 1 depreciation, times post year 1 depreciation. That's it. And then I want to output current value. Too many arguments. I did not. Oh, sorry, I put year instead of year frac. So it's saying that error message was you entered too many arguments for this function, which is true because the function I entered is year. I meant to enter year frac. So thank you, Excel. And so we see Mr. Smith's car, which again is exactly 1 year old, loses 20% of value in the first year, so you'd expect it to be down to 48k, and it is. And by the end of another year, you'd expect it to lose 12.5%, which is another eighth of its value. So an eighth of 48,000 is 6,000, gets down to 42,000, exactly what you'd expect. And then Mrs. Smith's car is exactly 1 year older, so you would expect its starting value to be that 42. So hopefully when we copy down, we'll get 42 here. We don't. So we might have a row locked. Yes, we do. So again, this is why it's important to do these sense checks. So you can see here, when I'm figuring out years old, I locked in the row as well as the column. So you're going to fix that, copy down, and now we see Mrs. Smith's starting value is the same as Mr. Smith's ending value because they're same purchase price and it's exactly a year older. And then it ends up at 36,750. And then finally, cash is just straight from the assumptions. I guess they just took this from their, I was going to say they just took this from their bank statements, but I think this is meant to be a forecast, or maybe it's not meant to be a forecast model. Anyway, all right, so there we go. So we've figured out, I don't know why that line isn't bold. I wanted that to be bold. Anyway, so we figured out total business equity, total real estate, total value of stocks, total value of cars, cash, total assets, mortgage liabilities, total liabilities, and you net the two off and you get net worth. And then the questions on this one were basically all just kind of, checking whether you'd got this. The only twist that was added to it was, I think, business concentration, which asked, what proportion is the business of his total net worth, and how that changes over the years. So you can just add that, just like that, and that's it. So, you probably would, even I might, consider this a slightly extreme example of in-cell documentation, but I hope it gives you the idea that, you can use let. Maybe this is a more, justifiable example where, you get a lot of the benefits of having built out a whole supporting schedule, but you also get this total compactness. So it's not even that you look here and see on what tab you can find the details and the logic. It's just you look in this cell and it's all spelled out here. The purchase price comes from here. How many years old it is, it's just a year frac from a starting date to the current date. Year 1 depreciation, this. Your post year 1 depreciation is this. Current value, product of those three, and away you go. So I quite like let for in-cell documentation like that. I guess very quick aside, although probably everybody stopped watching the video by now because I know nobody watches my very slow endings. But very quick aside, in case you are still watching, tiny bonus. The sort of old school pre-let way of doing some of this kind of documentation. Let's just take this one as an example. If I wanted to document the idea that, this was the number of shares and this was the share price, then what I can do, sometimes would do, is something like this. So this is going to say share price. So basically, n is a way of taking the numerical value of something, and if you give n a text argument, it returns 0. So anytime I add 0, it doesn't change the value. So I'm just putting it in brackets, obviously, so that it doesn't get, this plus 0 times that. So this is saying, here's a thing, and this is a note saying that thing is the share price. Sorry, not share price. This is a number of shares. Let me just cut this out because I am going to document share price in a second. Let's say number of shares, and then times this whole thing, which is share price. And you can see if I kind of fill that down and across, it doesn't change any of the values because these, actually, let's just pop it up here. Sorry, I couldn't sell for that. So it gives me 1,000, tells me that's the number of shares, but then that just adds 0, stays as 1,000. Gives me share price of 157.7, tells me that's the share price, but doesn't change anything. Multiply the two together, and you're away. So this is, especially if you're worried about backward compatibility, your clients don't use LET, or you don't have the current version of Excel, it's a little bit the poor man's way. It's not nearly as powerful as what you can do with LET. But, if you're, let's say if you're kind of pulling things together from lots of different, calculation tabs or supporting schedules or something like that, then you might want to label, like equals this cell, which is the current value of Microsoft stock, plus this cell from another tab, which is the current value of Tesla stock, or something like that. So that's another kind of way that you can do some in-cell documentation, which can potentially spare you having, larger supporting schedules like this. Again, there's a trade-off, but I'm going to stop talking now because I went on too long in the first take. I don't want to do that again. All right, thanks for watching. See you next time. Bye-bye.